Number 50. Find the domain and range of the function f of x, which will be y, right? F of x equals x plus 1 squared minus 5. Let's get a sheet of graph paper and write y for f of x here. Okay? Now the very first thing we want to do is find the vertex. Now the formula for the vertex is x minus h squared plus k, where h then is going to be the opposite of the plus 1, which will be a minus 1. Okay, so my vertex will be negative 1, negative 5. Okay, so my point for my vertex is 1 to the left, that's a negative 1, and 1, 2, 3, 4, 5. Now here's another thing to think about it. The vertex, the lowest point on the graph or the highest point on the graph, but if you let x be a minus 1, the opposite of this number right here, let x be a minus 1. The way I think of the vertex is this. What would x be that would turn this whole thing right in here into a 0? Okay? If x were a minus 1, the opposite of this number, if x is a minus 1, then you have minus 1 plus 1. What happens? That's a 0. And that's the simplest case I can think of, is when x is a minus 1, this turns into a 0, because I get to square 0. Okay? So whatever this number is here, take the opposite of it. Take the opposite of that number, because we want to get rid of this here. We want to have a negative 1 plus 1. So if you let x be the opposite of plus 1, you'll have minus 1. Then this whole thing here turns into 0, and y will be negative 5. That's another way to think of vertex. You can think of it with the formula, or you can think, what would x have to be to turn this whole thing here into a 0, or y will be the negative 5. Okay? All right. Now another point. We want to get another point. Well, a very simple point is let x be 0. If x is 0, you have 0 plus 1 is 1. 1 squared is 1. So you let x be 0. You have 0 here, right? 0 plus the 1. That's 1. 1 squared is 1. 1 minus 5 is a minus 4. Okay? So when x is 0, y is minus 4. That's 0 on the x scale, so it stays right here. It's called the y-intercept, by the way. And we're going down 1, 2, 3, 4. Now my vertex has a line through it called the axis of symmetry. And symmetry means I can fold my vertex, my parabola up, because I'm going to have a parabola going like this and like this. It means I can fold the parabola up, and whatever point's right here is going to be right over here. Okay? Because it folds up on this line right here. You think 1 to the right and up 1, you can think 1 to the left and up 1. So another good point would be right here. And that's the point 2 to the left and down 4. Okay? Now watch, if you put negative 2 in here, this is pretty cool. If you put negative 2 in here, negative 2 plus 1 is a negative 1. 1 squared, negative 1 squared is 1. And 1 minus 5 is minus 4. So this point does work for this. Okay? Now another good point I found to be 2 to the right and up 4. 1, 2, and up 4. How do I get that? Well, if you put 2 in for the x, you have 2 plus 1. What's 2 plus 1? 3. Square the 3, you get 9, right? So 2 plus 1 is 3. 3 squared is 9. 9 minus 5 is 4. That's where the 4 comes from. Okay, so 2 to the right and up 4. Now my axis of symmetry says if I fold the thing along this line, the parabola along this line, then whatever I have over here, I'm going to have over here. Okay? So like right here at this point here, I'm going what? 1, 2, 3. If my axis of symmetry, which the line going through the vertex goes straight up like this, then if I go 1, 2, 3 and put a point, I can start over here and go to the left 1, 2, 3 and put a point right here. Okay? You see, as you fold this up, this point lines up with this point if you fold it along this axis right here. You went 1, 2, 3. You're going 1, 2, 3. And that's the point 1, 2, 3, 4 and up 4. Okay? 4 to the left, up 4. Now let's check this point with our equation right here. Negative 4 plus 1 is a negative 3. Negative 4 plus 1, negative 3. Negative 3 squared. What's negative 3 times negative 3? 9 once again. Remember we had 9 a minute ago? We have 9 minus 5, which is 4. Okay? Now we'll draw a line through here. Okay? And the question, the original question, it's been a long time since we listened to the question, but the question says, what is the domain? Alright, now you see how you have arrows up here? that means it goes forever up, forever up. And if it goes forever up that way, then it's going to go forever to the right this way. Okay. As this extends farther and up, you see x changes as y changes. And it goes up forever and ever and ever, so you're going to the left forever and ever and ever. So the domain starts out here at negative infinity and goes to plus infinity, because this thing's going to keep on going. There's your domain. And you'll put, it's an open interval because you never get to infinity. Alright? Now the range. What is the lowest that y is? Well, here's 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1, 0. Here y is 0 on these 2 points. 1. Here y is negative 1 right here. You went 1 down here, didn't you? And 1 down here. There's negative 2. You're going 2 down. 2 down. 3 right here. 3. We're going 4. We even got negative 4, didn't we? Huh? Alright, right on these 2. Huh? And then what's the lowest that y is going to be? Down here at the what? At the vertex point, right? And indeed, you have a point at the negative 5. So negative 5 will be a closed interval because it comes down. Here's the point. The point is negative 1, negative 5. The lowest y can be here is going to be, it can't go down here at negative 6, negative 7, negative 8. So the lowest it could start at, the point farthest down is negative 5. And then how far up does it go? Forever and ever and ever. There's your range, and there's your domain.